if you moved your phone up at 9.8, it's the phone is going to register you're moving up. It's not going to register that you're just because you're canceling out the 9.8 that would be on it. It doesn't say your phone's not in motion. It knows it is, which means it has to cancel out the original 9.8
It'll
at rest.
add to the 9.8. If you accelerate it up, it'll add to the 9.8.
Yeah.
Right.
They
Yeah.
only,
Yeah. You're right. I said that slightly wrong. But yeah. Well, Jason, since you're here, what are your thoughts on this? Like in terms of like with all this, in terms of like if there's any motion with the Earth and the accelerometers and
Yeah, it just comes down to, with me, like a proper acceleration, in my opinion, requires a force. This real acceleration requires a force. Coordinate acceleration would be like what's caused by a pseudo force, which is basically the reference frame. If the reference frame is what's accelerating, really accelerating, then objects inside the reference frame would be experiencing a pseudo force. And so, how do you know the difference between which one is proper accelerating and coordinate accelerating? Would be an accelerometer. You could say that the accelerometer on the ground is measuring a proper acceleration upward, or that everything is being accelerated down equally, so that there's no difference whenever it's in free fall. I mean, you can interpret it either way. To me, it makes more sense that the acceleration is upward than a force that cannot be replicated in any way whatsoever to accelerate all forms, states of matter equally, no matter the mass or quantity. Everything accelerating down exactly equally. That kind of force. Yeah, it's not replicable, and I don't see it. It makes more sense to me that everything is just accelerating up. The ground's accelerating up, and everything in the reference frame, is going to the ground because of the force up.
So you're saying the ground is accelerating at 9.8?
Yeah.
So then I know there's always that question people ask, like, this is like the equivalent, like the first thing whenever someone mentions the dual pole, they're like Pac-Man. They have to say Pac-Man because of the east-west circumnavigation. The equivalent of this is with the upward at 9.8. It's like, so are we going at quantum light speed, like ludicrous speed right now? If we're
probably
always
like plaid speed or something. Yeah, like plaid speed probably. Yeah, but relation to what though? And why is there a speed limit?
So your answer is like if it is, from the accelerating up idea that it could be going at multiple times the speed of light or whatever. Like,
so in relation to something outside of the reference frame that we could never see or get to or reference to, maybe, probably. Yeah, all we can measure inside the reference frame would be the force underneath our feet. The speed relative to anything outside of the reference frame, we have no idea. And there's nothing to me that can dictate why we wouldn't be able to go, why there would be a speed limit. If all we can do is experience what we're experiencing inside this reference frame.
It makes me think of like teleology, like a goal, like goal oriented, or like a goal, like because if it was accelerating like that, it seemed like from that idea, it's like we're really moving towards something. Like where are we going, kind of thing, at that rate. Right. But I guess it's just my like human conception of it. Because like what's beyond this realm? Yeah, I mean if it's infinite or eternal, then that brings a whole nother facet into it. And obviously in the globe model, they say outer space is infinite, so they go on that right. idea.
Yeah, and all I can experience is what I can experience, and I don't think we can go, outside the reference frame or even up to where the stars are if they're real or whatever they are. We can just experience, what we have here.
You can't go there yet.
Yeah, that's true. Never know what's going to happen.
Do you think the ground has to be rising up like that at an accelerated, like, you think that
it would have to be
account for things dropping?
In order to suffice like the laws of motion, yes. Is there an instance like that everything, like the only other way, in my opinion, that it works is that everything is accelerating equally down together at 9.8 meters per second squared, which is like what Newtonian says, that's why you don't measure an acceleration in free fall, is because everything is accelerating together. Like you said, with jumping off a cliff, that is an interpretation of it, and that could be what's happening. But
hey, Jason,
real acceleration requires a force.
Have you ever heard that things go down for the same reason they go up?
Things go down for the same reason they go up?
That's the same mechanism.
What would that mechanism be? What do you mean?
That would be equilibrium.
Well, if something is accelerating, you have objects in free fall that appear to accelerate to the ground at a certain rate, and every state of matter follows this and follows exactly the same rate. So either everything is being affected by this force that knows exactly how much force to apply to every state of matter to make it accelerate the exact same amount, or the ground is accelerating up at 9.8 meters per second squared.
What if the ground is just where it is, and like, not to sound corny, but like water falls and fire flies by the same mechanism?
Well, yeah, I mean that's possible. It doesn't follow laws of motion that can be demonstrated.
Well, in terms of because obviously
even with no, go ahead. Sorry, Joe.
Go ahead.
I was just going to say, with there's an example of like buoyancy. Buoyancy, seems to be only can be created by a force. The globe model, or I guess the Newtonian model, says that buoyancy pushes up while gravity pushes down. But how can you have a force pushing in two different directions at the same time? If in the Earth rising up model, it would just everything's being forced up. The lesser dense items go up because they're being pushed by what's underneath them. The more dense items underneath them.
That's how it works in our model too, though. In our model, everything's being pulled down, including the things that are being displaced upward, like balloons. Those are just being displaced by other things that are being pulled down.
So there's a force. There's a force pulling down, but also pushing up.
No, there's a force pulling down, and it's like if there was like a bunch of people heading somewhere, and some of those people are more important. They're going to push the less important people out of the way. Everyone's being compelled towards that place, but those other people are pushing the less important people out of the way. It's not, but it's a single force that's doing that, though.
I got you. Yeah, it makes more sense to me that there's a force in one direction, and it's the more dense items are at the bottom, and they're pushing the less dense items up to the top, and that can be demonstrated in any other direction. What can't be demonstrated is a force in two opposite directions, other than begging the question of gravity. Unless you could show me something like that in another direction, where a force can push things two different directions.
Yeah, if anybody here could demonstrate what Jason just asked, I would be all ears.
What's that? A single force causing something to go in two different directions?
Yeah, other than gravity.
Other than gravity. Gravity is one of the examples. So gravity causes buoyancy in one example. In another example, we can describe like that guy Smarter Every Day did in his car. He's driving in his car. So he's got the same mechanism, the air in his car and the balloon. The car is causing, or the acceleration of the car is causing the car to go one way and the balloon and the air to go the other way.
Which is exactly what Jason is saying. That's the opposite of what you were saying.
No, that's another mechanism of what's causing that. That's a single force.
Wait, what's going? Right, the car's accelerating one way. What's going the opposite of the car?
The balloon.
No, the balloon goes the same way as acceleration. Like a helium balloon?
Yeah, helium balloon.
Yeah, it goes the same way as acceleration. Every time.
I mean, when it's braking. When
it's braking, then it's decelerating. And then it would go the other direction.
But they're going in two different directions.
Well, it goes the same way as the force. Let me put it that way.
No, I think what it means is when the car accelerates, the balloon inside the car is moving forward. And when it decelerates or brakes, the balloon is moving backwards.
Right, so the opposite.
Yeah, because then when it accelerates, the air in the car will be moved towards the back as the car is moving. Try to stay still when the car moves forward, so you get higher density in the back.
Right, so that's acceleration in two different directions that's causing the different direction. It's not the acceleration in one direction causing the two different directions.
Yeah, the acceleration is changing the distribution of air molecule inside the car.
Right.
So it's not, yeah.
Well,
that's all that we're saying is what's happening in the atmosphere as well with the balloon. It's the same mechanism, just in a...
Wait, so everything is accelerating one way, but something else can be going the other direction?
Because that's what I'm saying. There's heavier air that's displacing the balloon. There's not the force isn't moving the balloon the other direction. It's just that the air is has more precedence than the balloon does. So it pushes the balloon. It's displacing the balloon. That's what's called buoyancy.
Buoyancy and density in comparison to what you would call gravity, and how they all interact. The buoyant force can overcome gravity at times, even though gravity's still acting on it. You would say, or the buoyant effect.
I didn't hear that first part.
I was just kind of restating your point, asking if that's what you meant, sort of. I was just saying, I'm just saying buoyancy and density, and like in the mainstream model, and how that contrasts with gravity. Now, buoyancy and density interact. They would claim that gravity is always acting on it, but then buoyancy and density can make alterations basically within what's already happening to the object from gravity.
Yeah. Well,
helium being they would still claim gravity is acting on helium, but helium has a buoyant effect that allows it to contradict or kind of go against the gravitational force.
Right. The density is what determines it. So the density of the other air has more precedence than the helium, and so it's being displaced out of the way. Yeah, exactly.
Well, Jason, let me ask you this: okay, so obviously the mainstream model is going to, they have the mass attracting mass and the bending warping space-time and all of that. There's discussions in the ether perspectives of electrostatic force of, but I don't know that anyone has really nailed that down to get to the exact spectrum or what that might be. And then there's different ideas as well, and then we're talking about the upward moving Earth surface to account for this. But I guess what I want to ask you, if there was a force, let's just call it force X right now, if there is one, whether it's let's just say for the moment that it is an electrostatic and it's just a yet undiscovered spectrum. Sort of like the sun has ultraviolet and UV or UV and all the radio waves, all the different parts of the sun spectrum, visible, infrared, etc. Well, if and I'm not trying to put this force as an entire theory or trying to assert it. I'm just trying to use an example. So if there is, let's just say a force X, and for the moment just electrostatics is the way of something to put our minds on, but it's not fully understood or discovered yet. If that was the case and that force X was acting on all matter, to cause the acceleration 9.8, would that for you shift you from the upward moving to, okay, was force X going down to stationary, or are there other issues with stationary that even force X wouldn't solve? I guess that's kind of my question.
It would be a big jump for me. Yeah, if something like that could be demonstrated.
Yeah, would it cancel out the
How-
requirement for an upward moving
Something
Earth
like what?
surface?
What would you like to be demonstrated? You got
Cancel. Yeah,
something
it
like
still
that?
seems like a big problem to me that that a force and acceleration will cause atoms to go in two different directions. Force in one direction causing displacement in two different directions. I need to think about it a little bit more, like what Kojo said, but it practically demonstrated. I haven't seen that, but yeah, as far as like being able to duplicate, replicate, demonstrate that kind of force, if something was able to do that, then yeah, definitely it would hold a lot of weight.
Well, I
No
have a
pun
question.
intended.
So let's
Right.
also let's assume dielectricity is the reason things fall, right? So that's the reason all these things are falling. It's the reason the accelerometer is falling. How do you think it proved? Like, how do you think it would? You think so? You don't think that's the case? So if that was the case, you think the accelerometer would do something different when it's dropped?
I don't understand what you just said. You cut out a little bit. Say it again.
Well, you guys bring up the accelerometer. I'm just wondering how if your guys are claiming the upward Earth is making things fall, and we're claiming dielectricity is making things fall, how would the accelerometer behave differently? That you guys claim the accelerometer proves like the upward Earth.
Well, you would just have to demonstrate, electricity causing a force to equally accelerate everything down together.
No. That's
Well, that's the only way that it would change an accelerometer,
I'm
or
just
it would
asking
equal an
how it would
accelerometer reading.
how the accelerometer would be different in each model.
I think he's saying it would be the same, and then
How would it
you'd
act
have to
different?
prove the force. Is that what
Right.
you're saying? Yeah.
Right, exactly.
Yeah, no, he's
Well, you can
he's
manipulate
asking for-
electrostatics to change something, right? But that doesn't prove
Yeah,
what the
wasn't
thing
asking-
is.
As far as I know,
was
Jason,
asking
right now
how
you're
accurate-
not. You're a little bit delayed, Q. Hold on, Jason. As far as I know, you're not right now claiming that the current observation of an accelerometer is exclusive to an upward motion Earth, right? Like you're not claiming that, meaning there could be something else, but you're just talking about all the physics and the components of
Yeah,
it.
in the physics that are known right now, that's without begging the question of gravity. That's the only way it works for me. Like if you beg the question of a force that can equally accelerate all states of matter together, then yes, the only answer is the Earth upward accelerating. But if it can be demonstrated that a force can do that, or there is a force that can do that, then it's special pleading for me not to go with what can be demonstrated.
Doesn't the Van de Graaff generator kind of show that?
It just shows that you can
Everything-
manipulate a
everything-
force. It doesn't say what force you manipulate. It doesn't say you're manipulating the force that makes everything accelerate down equally.
but it makes the things not accelerate down anymore. Makes
You're
them
changing the vector.
go the opposite direction.
Yeah, but I could take an air blower and levitate a ping pong ball. I mean that's doing the same thing.
It's not doing the same thing.
I mean, you're just manipulating another force.
I see the overlap in what he's saying. I mean, air. One of them he's saying blowing air, but the electrostatic one, you would have to agree though, it's a little different because it's like it's
Just
an
like
electrostatic field though versus like air. Like air to me seems more of a physical.
You're literally
application.
changing the charge of the. You're literally changing its charge.
Okay, so then everything you're saying a specific charge makes everything go down equally, but if you manipulate a charge of one thing, then that one thing goes up and changes the vector of that one thing.
Wasn't it like the one guy said, equilibrium? Like everything's, but you change the charge and it's trying to find the equilibrium. Once you
Equilibrium, yeah.
change it.
I mean that kind of makes sense to me, other than the fact that real acceleration requires force, and seeking equilibrium, does that mean that there's a force pushing it to the equilibrium? Because what we measure is an acceleration of objects in free fall towards the ground, whether that's up or down. That there's an acceleration there, and if it's a coordinate acceleration where the frame is just accelerating up, then the force is on the frame. If it's the item being accelerating down, then there's got to be a force that accelerates it.
Yeah, so if you're saying that you haven't seen well, of course, this is the whole question of what is gravity. I mean, even the mainstream will say we don't know.
Right.
There's all these theories. So yeah, it's a huge question. It's not like this is some even thing that the mainstream claims that they have, even though they use gravity with their on the generalized scale with their kind of chest pumped out. I'm not talking about anyone in particular, but they go at it like because they need it for their global model and all that. But if you're saying you don't know like a force that force, but why would you then have any bias towards an upper motion Earth if you don't know what the source of the upper motion of the Earth is?
Well, it's just something that I couldn't reach anyway. Just like in the regulars, in a stationary flat Earth model, we don't know what the stars are. You don't know what's up there. I can't apply physics to things that I can't see, manipulate, and physically test myself. But
Okay,
what
so
I can apply physics.
Because it's
Right.
outside of the frame, you're considering it could be the case that you can't access it more than something that has never been shown to you in the frame you're in, basically, as a comparison.
Right.
But doesn't it still seem like a leap though? Because the force that would have to move the Earth up would be quite
definitely.
something.
You're definitely right.
It would have to.
But
It would have to
it's
be.
not-
It would have to be. It would have to be continuously accelerating because you would.
yeah, we've been over
If it
this.
was going
Yeah.
at one speed, you would just be able to jump in there.
Right.
And float.
Nobody. I didn't claim a constant speed.
Okay, so how? So what are we going? Infinite speed?
Maybe. I don't know. We're
And how is it
accelerating
going? It can't be accelerating slowly either.
9.8 meters per second squared, bud.
It's not how.
I don't know if you were here. I asked him this. We talked about this. He was saying that essentially it could be going at really fast speeds, basically, like the that it would just
Right. If
continue.
there's not something to relate the speed to, like in my interpretation of what's going on is what I see is, and what I can measure is a force underneath my feet, and that force,
Why is that?
a constant force will produce a constant acceleration. Period. Can be
Why?
demonstrated 100,000 ways,
But if
and
the whole
not a
Earth is
constant
moving,
motion.
the whole Earth is moving at the same speed because it's all together. How do you
Right.
have
Like
different?
the whole
How
system.
do
The
you
whole
have different?
system.
Yeah, how do you have different weights at different altitudes, which are correlated with? It's only like a couple correlations you can make with altitude, which is like the air or the charge in the air, which is the same thing,
Okay.
basically.
So you're manipulating a different variable.
I'm not manipulating anything. I'm just at different altitudes, things weigh
At
different.
different altitudes, air pressure may be different. I mean, that's a different variable that would cause things to be different. But does that mean that air pressure is what's causing the 9.8 meters per second squared?
No, there's an electric gradient, and as you move in
So
it,
this linear electric gradient of 100 volts per meter is causing acceleration of 9.8 meters per second squared?
it's no, the gradient itself is not causing it.
Oh, what's causing it?
We're leaving the vortex.
Oh,
So,
vortex is
Kilo,
causing the acceleration?
do you mind if I ask a question real quick?